day now. Okay, 36. I was like, if it does it again, I'm just calling it a day.
That's enough.
Yeah, I'm done. All right, so these ones say to use the cylindrical shell method to find the volume of the solid generated by revolving the region bound by the curves about the y-axis. So we've got y equals x squared, y equals 2 minus x, and x equals 0, and we're doing this for x greater than or equal to 0. Which that's really only going to make a difference if we have dimensions on our, like the parameters of our integral that could be less than 0. We just have to do it basically from 0 to whatever the positive one is. Now, if they all are positive, then it's irrelevant. But typically, if they're telling you that, you're going to need that. So, I would say, like, do, like, a little rough graph of this first is probably the easiest thing to do. So I'm going to do a little sketch here. It obviously doesn't need to be super big. So we've got basically a baseline parabola. Oops. And then I've got, I know that it's x equals 0, so I know there's that one coming straight down. And then I've also got, I don't know why I just did them out of order, but I did. 2 minus x, so that's here, down 1 over 1, down 1 over 1. So the area that's bound by all of this is in here. So, the form for this, just because it's been a few days since we did this, is 2 pi. Obviously, it'll have the dimensions on it. I'll just put A and B for now. Times the shell radius, which for this one and the other one that I worked out, that's a little bit longer. In both cases, the radius is x. Because we're revolving about the y-axis. So the radius is obviously how far away we are from the axis. So it's going to be x. But anyways, we'll add that in a minute. Times the shell height. And then dx, not dy. I was about to write dy. So in order to figure out what my parameters are of where I'm doing this for, I need to set the two equations that are y equals something equal to each other and solve. So I'll have x squared equals 2 minus x. Now in order to keep x squared positive, because that makes it easier for factoring, I'm going to move everything to the left. So x squared plus x minus 2 factors into x plus 2, x minus 1. So I get x equals negative 2 and x equals 1. Now, I'm told that x equals 0, and I'm also told that x is greater than or equal to 0. So that means that this negative 2 can't actually be one of them, right? Because it's not meeting this criteria here. Now, the other obvious place then is 0, and so I'll also be using x equals 0 as the other one. So I will be going from 0 to 1 as far as the parameters. Now, something else that it's not really needed in this, but if we wanted to find the points of intersection, we would take these x values and plug them in and find y. We don't really need that for this problem, but it's just kind of another good thing just to kind of refresh on that. So anyways, like I said, the radius is just x. Now the height is going to be top minus bottom, and I'm not using the x equals 0 because I'm using that as one of my like parameters, so I'm not really looking at that. So I'm looking at the green and the blue. So the height is going to be 2 minus x and then minus x squared. Now sometimes people will do this and put the parentheses around that just to show that that was like all one piece, but ultimately it doesn't really matter.
Why is it that point, like the height?
So it's the top one minus the bottom one.
Okay.
So 2 minus x is the green line, and that's why you have to graph it.
So the x minus 0, like we don't, like that one's not.
That's setting the parameter for us basically, because I'm going to be integrating from 0 to 1. Now in the, let me see, in the second one that I did though, they did not specify that. All they specified was that y was greater than or equal to 0. So you have to just, be aware of that. Anyways, what? Hold on. Don't go off. Mr. Fletcher was sending something and I was like, probably should go ahead and respond to this. Did I answer your question?
Yes.
Okay. I was like trying to remember if I finished answering your question because there was like this whole stream of messages between the teachers coming through and I was like, I don't know what's happening. Okay. Anyways, so now to find the volume. And I have this in 1, 2, 3, 4, 5, 6 lines basically, but it just depends on, this would be my like second column of stuff if you want to start your other column. And if you work left to right, then it won't take you that many lines. But anyways, now obviously up here I showed you that the 2 pi is inside. I'm going to put it out front just because it's a constant. So 2 pi and then the integral from 0 to 1 of x, so that's the shell radius times the shell height is this, so 2 minus x squared dx. So that ends up being 2 pi times the integral from 0 to 1 of 2x minus x squared minus x cubed dx. And then now I just have to integrate this. So 2 pi times, what is the antiderivative of this?
X squared minus 1/3 x cubed minus 1/4 x to the 4th.
And evaluated from 0 to 1. So I just am keeping the 2 pi out front until I'm ready at the end. So then that's just going to be 1. Because I'm just plugging in 1, I'm not going to actually show writing it in, but just know that it's being plugged in. So 1 minus 1/3 minus 1/4. And then technically speaking minus 0, because all of those are going to end up being 0. So common denominator, again, I have this as a totally separate step. I was going to say whole and then totally, and then it just went together. Anyways, so I've got 2 pi times 12 over 12 minus 4 over 12 minus 3 over 12. So then that ends up being 2 pi times, 5 over 12, which gives us a grand total of 5 pi over 6 for the volume. So 38 is just a lot longer than that, so I'm going to make a copy of this for you. I'm not going to make you do both 35 and 37, but those are both those types, so you can just choose one. I don't know which one's easier. I did not work those ones out.
What was the first set of homework problems again?
Like, not from earlier. That was just 39. That.